H2SO4, what's the name of this acid? Sulfuric acid.
Yeah.
So concentrated sulfuric acid is used as a drying agent when we are preparing both carbon dioxide and oxygen. Alright? And then this gas collect in an upward displacement. Alright, so basically the equations remain the same. Alright, so as you can see, so for example, if we want to produce oxygen, what would we put here? Hydrogen peroxide again, right? And what would be we have as a solid here? Manganese oxide, MnO2, solid. But this is the catalyst, right? Right? And then here we're going to produce the oxygen gas. But the important thing is that, so here is oxygen gas going here, you know. But the concentrated sulfuric acid will absorb all the water vapor that may escape over here. Clear? So the oxygen that is here would be actually dry. That would bubble through here.
Sorry.
Sulfuric acid?
No, the oxygen. Oxygen, I said dry. Yes, sorry.
When I said dry, it means it has no water vapor mixed with it.
No water vapor.
Yes. Because for example now in the atmosphere inside here, we have oxygen gas, we have nitrogen gas, we have carbon dioxide gas, but we have water vapor here. You know. For example, when they talk about humidity of the air, it's just referring to the amount, the percentage of water in the air, in the atmosphere. So the higher the water vapor content in the air, the more humid the place is. So when the time is rainy or so forth, you can see that air is feel a little wet. If the sun is hot and the time is dry, the air is a little dry and you might even feel like a little, your nose or your lips make it dry. Alright? But in this case, why do we collect the gas oxygen or carbon dioxide in an upward displacement? So remember that initially you will have air in this gas jar. We're going to be producing the gas, but we put the gas here and we leave the cover of the vent at the top for it to come out. Why do we do it like this? For carbon dioxide and oxygen.
You what?
Why do we collect the gas? Because it's an exam question. You know. Why do we collect oxygen and carbon dioxide in an upward displacement? So as you can see, this gas jar, we turn it upside down, you know. So
the element above it is lighter.
Because
it's lighter than the element above it.
because carbon dioxide is denser than air. It's heavier than air. Because remember that air is mainly nitrogen and oxygen, and the carbon dioxide is way heavier. So it will be, if you have supply this gas jar with lots of carbon dioxide, it will displace the air out. So all the oxygen and the nitrogen will escape out until this is full with carbon dioxide. Right? Likewise, the oxygen, it is slightly denser than air. Because remember that oxygen is 32, the major component of air is nitrogen, which is 28. So it will also displace all the nitrogen from the jar and leave pure oxygen inside here. Alright? Just put ammonia. One, two of them. This is NH3 gas. I said ammonia, it's a gas, alright? So, Yeah, flat bottom. This is calcium hydroxide and ammonium chloride. Calcium hydroxide right, and it's decomposed to produce ammonia gas, H3 gas. Going here, here. Alright, so you see the previous apparatus with the with the preparation of dry oxygen and carbon dioxide that continue with the sulfuric acid is called the wash bottle. I don't think I named it. And then you normally put a litmus paper here. Moist red litmus paper. No, so this is ammonia gas that will be formed. No. Alright, so in this case, as you can see, the ammonia gas is collected in a downward displacement because it is lighter than air. Because ammonia is NH3, as you can see, this is 14, 15, 16, 17. Majority of air is nitrogen gas, which will be about 28, and that's just 17. So actually, in this case, it's a gas that is lighter than air, so it is downward displacement of the air. So the ammonia will stay at the top, right? No. They use a moist red litmus paper because ammonia is a basic gas. And like most of the other gases are acidic gas, right? So remember that most metal oxides are acidic. Sulfur dioxide will form sulfuric acid. Nitrogen dioxide will form nitric acid when dissolved within water. Carbon dioxide will form carbonic acid in water. So most non-metal oxides are acidic gases, right? But ammonia is a basic gas. So it will actually dissolve in water to produce ammonium hydroxide. Right? So it's probably the only basic gas. That's why it's so easy to test with the red litmus paper, because litmus is red in acid, and will change blue in base. Alright? So if we have the moist red litmus paper here, the ammonia gas will react to form ammonium hydroxide on the paper, and it will form the base, which will change it to blue. Alright? So remember that the same apparatus could be used to prepare oxygen and carbon dioxide dry, except that it's calcium chloride you would use as a drying agent, right? However, ammonia gas cannot be prepared with the wash bottle because ammonia is going to react with the concentrated sulfuric acid. Alright? So if in the exam you go and put the wash bottle in the preparation of ammonia, you will get it incorrect. Alright? Because you have to know that principle. Clear that the ammonia gas, you cannot pass it through sulfuric acid as the drying agent. And it can use calcium chloride here because it will react with it as well. Ammonium chloride. Alright? But we need to write the equation. You will require it for the exam. So it's going to produce calcium chloride, ammonia, and water gas. Right? Two here, two here, two here.
Between brackets.
Yeah?
Or between brackets. Calcium chloride between brackets.
Oh, sorry. Thank you, that doesn't make any sense. That's solid. Alright?